Your transaction didn't fail because Solana was congested. It failed because of that one piece in your stack that you didn't think of, your RPC connection. Now every wallet, every bot, every dApp talks to the chain via a RPC endpoint. However, no one is actually measuring how fast theirs is. Hi everyone, my name is Benjamin and today we are going to fix that because we are going to build a small tool that races multiple RPC providers head-to-head on the exact same calls, clocked to the millisecond. Then we are going to hand that data over to Claude and it will write the entire results page for us, meaning the report that we will have at the end of this video will be written by AI based on our own raw data. And on top of that, all the code will be available for download via our GitHub repository. And as always, for more information, you can visit our official documentation or join our great Discord community. Both links will be in the description. Now, before we are going to test anything, you need to know what we are actually going to measure. So let's talk about RPCs first, what they do, and why the speed of an RPC can make the difference between landing or missing a transaction. So here is the thing that nobody tells you when they start. Your bot doesn't talk to Solana. There is no central Solana server. Solana is about 1,000 validators, and of course, you're not one of them. So how does your app read, for example, a balance or send a swap transaction? It asks a node. That node is a RPC. It does a remote procedure call. It's the door between your code and the on-chain. Want to check an account balance? That's an RPC call. Need a block hash before you can send a swap transaction? That's an RPC call. Sending the transaction itself? That's another RPC call. Every single thing that your app does on-chain goes through that same door. And if the door is slow, everything behind it is also slow. Now here is why milliseconds matter, and this is the part that nobody talks about. A block on Solana closes every 400 milliseconds, roughly. Whatever you're trying to do, you are racing to get into the next one. Say a new coin migrates and the liquidity goes live. The people who land that buy in the first block and the people who hear about it blocks later are not buying at the same prices. The gap is your RPC. Or if you are copy trading a wallet and it makes a swap, how fast does your RPC even let you know that it happened? Because if your node is slow in reporting that event, the move is already over and you're buying at the top. In trading terms, a slow RPC means that your exit liquidity for somebody else with a fast RPC. And yet, you are not testing your RPCs. You are never actually clocking it side by side under the same identical conditions. So that's what you will be able to do after I'll show you this code. So the whole thing is a small TypeScript CLI with one config file and 1 or 2 commands that you can run to start this whole thing. In the config file, I'll have all my providers, the public mainnet endpoints, of course, plus the paid ones that I have keys for. Now, every provider gets his own connection, and the keys are in these environment variables. Nothing is hard-coded, so if you want to add your own RPCs with their own keys, you can do that. It's also documented in the README, so it will only run the providers that you have the keys for. So if they are missing, for example, you don't have the keys for the example that I provided here, they will be skipped and you only raise the subset of RPC providers that you have the keys and the endpoints for. The test itself is really simple and that's the whole point. We are going to do 4 calls that every real app makes, and the first one is get slot, and that's the 100-meter sprint, I would say, because we are going to get the latest slot, and that is a pure latency test. Then we are going to do the latest block hash, or we are going to get the latest block hash better. And every single transaction that leaves your machine or that you want to send will need that latest or recent block hash. Then we are going to get account info for a big account, and this is a busy liquidity pool actually, and that tests how fast they can provide us real data, or how fast this RPC can provide real data back to us. And then we are going to get the signatures for a busy address, and this is where the slow RPCs will fall short because it tests the indexing of the RPCs and not just their ping speed. Every round, all providers will do the exact same calls at the exact same moment, and we are going to run about 50 rounds. So one lucky response doesn't win the race. Alright, so let's run this, and what you're watching here is 1 line per call every round. The fastest provider on each call grabs the green trophy, and anything that doesn't respond or has an error will flash red. And we also have indicators for freshness and anyone who is serving stale data. Same requests, same chain, same moment. And then when it finishes the run, it drops the full table, sorted of course. And one number to keep your eye on here, because we're not just looking at averages, is the P95 score, because averages, they hide the stalls. And P95 is important, of course, because it will show us the worst response or the slowest response that you will realistically hit. However, raw speed is only half of the story, and there is the part that most comparisons miss, in my opinion. When we ask these providers for the current slot at the same instant, they don't just answer at different speeds. Some of them answer with different slot numbers. And that means that a provider can be really quick in responding, but with old, stale data. It is really wrong, really quick. You get your answer first, and it is already history. So a fast but stale RPC is worse than a slightly slower, fresh one. This tool tracks both latency and freshness, both separate scores. Now, 50 rounds, 4 call types, many providers, that can be well over 1,000 data points. And of course, I'm not reading this by hand, and neither should you, so the results file will go straight into Cloud through the Anthropic SDK. We are going to do one call. It gets the raw JSON results and a instruction, of course. It will rank them, find the anomalies, and write us that report. And it will write that entire result page for us. It will create a HTML file with the charts, the verdict, the summaries. It will be one file. It will be able to open offline. There is no frameworks, nothing that we need to build. And here is the file that we get back. So nobody hand-coded this page. It came out of the model, built from the data that we just gave it. And it doesn't just summarize, it will also catch us things that you won't catch yourself. For example, the provider that is really fast at a certain time of the day, but it is really slow in indexing calls, or the P95 spike that only shows up for certain methods. A fast but still RPC, the thing that we just talked about. And of course, we have the tool to gather that data. We know that the data is proper. We feed it into the system and we get a proper report out. So what did we learn? 1. The spread is real. The gap between the best and the worst provider on P95 is big enough, in my opinion, to be the difference between landing a transaction and seeing it fail. 2. Indexing is the real separator. So on simple calls, every RPC looks good. On signature lookups, however, the field is more split in half. And 3, fast doesn't always mean fresh. You have to check both, always. 4, and this is the honest part of the video, these numbers are mine from my machine right now. Where you sit physically also matters. So if you sit close to your provider's endpoints, that will shift the results. Your connection, the time of the day, the plan that you are purchasing, all of this will contribute to the results, and it can shift this needle into your favor or out of your favor. So don't take my leaderboard as gospel. The point isn't my result. It's that you can run this from your own trading environment on the calls that you actually make. And 5, this is maybe the biggest one, measuring this took the time of just a coffee break. So there is no reason that you cannot get the best RPC possible. So you see, running this tool is actually really simple, and the report writes itself. What provider are you using to trade, and have you ever tested it yourself? Let me know in the comments, and maybe I do a follow-up video on the most mentioned. That was it for today. I hope you think it was interesting, and I'll see you in the next one.